Good day, everyone. And once again, we are back together. All right, we are still looking at that IEB November 2022 exam. So, of course, if you haven't subscribed, what have you been waiting for? All right, Uncle will continue to give you some good content. All right, let's have a look at question 7. All right, so they say to us we've got a satellite with a mass of 360 kilograms that is in orbit around the Earth. Right, they say the Earth has a mass of 6 times 10 exponent 24 kilograms and a radius of 6.4 times 10 to the exponent 6. Right, they say at a particular point in its orbit, the satellite experiences a force of 3.6 newtons towards the Earth. Okay, the center of the Earth, right? All right, so the first thing they say we should state Newton's law of universal gravitation. So please remember, Newton's law states that two bodies in the universe will attract each other with a force that is directly proportional to the product of their masses and inversely proportional to the square of their distance apart from their centers, right? So please always remember that law. If it happens that you struggle a bit remembering that, please just remember, all you need to remember is the formula, okay, over r squared. Okay, so the force of attraction between two bodies in the universe is directly proportional to the product of their masses and inversely proportional to the square of their distance apart from their centers, right? All right, now the next question, they say at what height above the surface of the Earth does the satellite experience this force? Now, the force that we had, so first of all, let's use our formula. Okay, so we know that the force was 3.6, right? So G is 6.7, okay, times 10 to the minus 11. Okay, of course, you can always say 6.67 multiplied by the mass of the satellite, that was 360 kilograms, multiplied by the mass of the Earth. This is given by 6 times 10 to the exponent 24. Now, the distance from the center of the Earth, I want you to think about it. So if this is the Earth and this is our satellite, right? So it will be the distance, the radius of the Earth, plus the distance away from the satellite, right? So let's say that's the radius of the Earth. Let's call it RE, right? And it will be the distance away from the satellite. I'm going to call it small r. Okay, so the distance would be RE, so it would be 6 times 10, 6.4 rather. 6.4 times 10 to the exponent 6, that's in meters, plus the distance r, which is the distance that we are looking for. They want to know what is the height above the surface of the Earth. In fact, maybe let's use h, instead of r, okay? So let's use h as the height above the Earth, right? Remember, this is squared, okay? So let's find out. So we're going to do our mathematical gymnastics. We're going to cross multiply, all right? So let's just whip out our calculator there, okay? So I've got 6.7, all right, exponent negative 11 multiplied by 360, that's 360 multiplied by, okay, 6 exponent 24. Right, I love using that exponent button, right, because it just makes things a little bit easier. Right, so that's what we get as our product, right? And then what are we going to do? We know that we're going to divide by that 3.6, which is the force. Okay, so we divide by 3.6, okay? And we are going to take the square root of this. All right. All I'm doing, ladies and gents, I'm just making the calculation from the calculator so that we just have the final answer eventually, right? So I'm going to take the square root of my answer. So the square root of our answer. Okay, we get that big value and we subtract from it. Okay. So now, all right, so we say subtract 6.4 exponent 6. Okay, right, so I get an answer of, at what height is this, right? And please do help me out if you are able to. I get an answer of 1.94 times 10 to the power of, looks like 8. Yeah, so I get 1.94 times 10 to the exponent 8 meters, right? That would be the answer that I get. Please just verify it for me. Okay, but nonetheless, we have done the right thing in terms of setting up the equation, right? All that's left for us to do is to work through those mathematical gymnastics. Please, in the comment section, please let me know if that is the answer that you get as well. All right, if it's not, please just make sure that you get to the right one and please comment, right? Now they say to us, what is the magnitude of the gravitational acceleration, right, at this point in the satellite's orbit? Okay, now remember, in this case, when we want to find what gravitational acceleration would be, we would say, well, this is going to be g multiplied by m over, now remember that our distance, we said it's the radius of the earth plus that height h, right? And this would be squared. So let's substitute. So that's 6.7 times 10 negative 11. By the way, you're given the value of g, right? So that's multiplied by, right? Remember, this is going to be the mass of the earth, right? So the mass of the earth, that's 6 times 10 to the power 24. To the power 24 and divided by the radius of the earth, we said 6.4 times 10 to the power 6 plus our height, we got 1.94 times 10 to the power of 8. And please remember, this is squared. Right, so let's calculate the gravitational acceleration at this point. Okay, and by the way, in fact, I just forgot about something. I'll just show you just now. So 6.4, okay. In fact, I took the long way around of calculating this, but I'm going to show you a shorter way just now. So this is 6 exponent 24, all right, and let's verify if we're going to get the same answer. And this is divided by that's 6.4 exponent exponent 6 plus 1.94, okay, exponent 8, and this is squared. Right, it looks like, that doesn't look right. Okay, get a gravitational acceleration of 0.01 meters per second squared. Okay, right, it is quite a distance from the earth, but yeah. Another way that you could have done this is that you remember that weight is equal to m times g, right? So we already had the force, the weight of this object away from the earth. The earth exerted a force of 3.6, right? And the mass of this object was 360. So in this case, what we needed to do was just divide the 2 by 360, okay? And you'll see that G would actually give us 0.01 as well, meters per second squared. Yeah, it looks like we've done the right thing. All right, so this would be the easier way instead of using the GM and all of that, right? Okay, so we've got the weight, which is the force of attraction between the Earth, the center of the Earth, as well as this satellite. And we had the mass of the object. Okay, right, so that gives us 0.01. I hope that's helpful, right? Now, we go on to the next one, 7.2. They say we've got two identical uncharged metal, light metal spheres, which are A and B, that are suspended from non-conducting strings, as shown. They say they are then charged so that A carries a charge of positive 2, right? And B carries a charge of 6, okay? So their charge are 2 and 6 microcoulombs respectively, right? They say the spheres are in equilibrium at a distance of 5 centimeters. So they get to a distance of 5 centimeters apart. Now, they wanted us to find out, once the spheres are charged, right? They want to know which diagram would best represent the position of the spheres, right? Okay, and in this case, I want you to please remember, it doesn't matter. For as long as the two spheres have got equal masses, right? We know that the force that A exerts on B will be equal to the force that B exerts on A. So it means in this case, they would actually repel each other with equal forces. So as a result, Z would be the better representation. Okay, right. So they would tend to move, in this case, in different directions. So I want you guys to simply note in this case that every time that we're talking about charged particles, they would have the same force, right? They would exert the same and equal amount of force on one another, according to Newton's third law. All right. Now let's go on to the next question. Right. Now they say to us, if the mass of A was significantly greater, now, which means A is now heavier, okay, than the mass of B, which of the three diagrams would represent the position of sphere A and B? All right. So now, if A was, was a greater mass, it would tend to be displaced a little less than B would. So the best representation in that case would be Y. Okay. So remember, B would be lighter, right? So as a result, it would tend to be displaced, or it would experience a greater acceleration than A would, right? Okay, so the next question, they say to us, calculate the electrostatic force between the two spheres, right? So let's remember the two spheres are 5 centimeters apart. They are 2 and 6 microcoulombs respectively, right? So I'm going to calculate the force there. So F is equals to K, QA, QB over R squared. All right, so remember Coulomb's constant, that's 9 times 10 exponent 9, multiplied by the charge of A, that's 2 times 10 negative 6. Now remember, you do not substitute for the sign in this case. The sign just tells us the type or the kind of force that it becomes. In this case, because they're both positive, it becomes repulsion, right? So that's 2 times 10 minus 6. That's also 6 times 10 minus 6, that's microcoulombs, right? And divided by the distance. Now, guys, remember, once my distance is given in centimeters, right? Remember, centi is times 10 minus 2, or you can say divide by 100, okay? So that would be 5 divided by 100, so that would be 0.05, okay? Right, so, but remember, we square that. All right, so let's try and find out. Okay, so we've got 9 exponent 9 multiplied by 2 exponent negative 6. Okay, I done something wrong there. 9 exponent 9 multiplied by 2 exponent negative 6. All right, please don't mind the noise in the background. Multiplied by 6 exponent no man, why do I keep doing the wrong stuff? So 9 exponent 9 multiplied by 2 exponent negative 6 multiplied by 6 exponent negative 6, and we divide that by the distance, which is 0.05, and that's squared. Okay, right, so we get a force of 43.2 newtons. All right, as I said, please don't mind the noise that is outside. Okay, I'm still in Mthatha, and the people are very excited outside. All right. Okay, so we've got that force there, right, which is 43.2 newtons. Okay, and we know also what type of a force it is. It's a force of repulsion, but nonetheless, the question asked us for just the magnitude of the force. Right, now, they say to us we've got the identical spheres A and B are brought together, right, to touch and then move apart, right? They want to know, in this case, what charge will each sphere carry after the charges have touched and separated again. Now, please remember, guys, right, that once I have two charges or two spheres touching, to get the net charge or the new charge, right, all I simply say is it will be the charge of A plus the charge of B, and we divide that by 2. Okay, so that's going to be 2 exponent minus 6. Now, this is the only part where you are allowed to take the sign of your charges, right? So that's going to be positive plus a positive 6 times 10 minus 6, okay, and this is divided by 2, okay. So what will we get from that? So 2 plus 6 in this case will give us 8, and 8 divided by 2, we end up with a positive charge of 4 microcoulombs, okay. So that will be the new charge. So the new charge of A and B, right, will be equal to 4 microcoulombs. Okay, right, now finally they want us to find out the number of electrons that have been transferred. Now I want you guys to note in this case, right, that A, which had positive 2 microcoulombs, right? So remember, once I have a positive charge, what it simply means or attests to is that it has a deficiency of electrons, right? But I want you to note A had positive 2 and B positive 6 microcoulombs. So which means B has got a larger deficiency of electrons than A does, okay? So what would tend to happen in this case, right? The one that has a greater supply of electrons, if you may put it like that. So A has got a better supply of electrons. It would tend to transfer electrons to B, right? And as a result, both of them end up having a positive 4 microcoulombs. So now B has got a little more electrons, so the charge on B is less positive. So in this case, it's positive 4. And of course, because A has lost electrons, it would have a positive 4 as well. Right. Now, how many electrons are we going to actually have in this case? So number of electrons, I want you guys to please note, it will be the change in the charge, right? So I'm going to take the one that received electrons, and it really doesn't matter whether you took A or you took B. So I'm going to take A, right? Sorry, I'm going to take B because that's the one where electrons were transferred to. So the charge of B, the change in charge in B divided by the unit charge of an electron, right? So what is the charge of B final? Okay, so that's charge of B final minus the charge of B initial divided by the unit charge of an electron. So that would give me the charge of B final is positive 4 times 10 minus 6 minus, in this case, the initial charge of B, remember, was 6. So that's minus a positive 6 times 10 minus 6. Okay, and this is divided by minus 1.6 times 10 minus 19. Okay, right, so let's try and calculate that change in charge there. Okay, that's 4 minus a negative 6, so that would give us minus 2 exponent minus 6, and we divide that by the unit charge of an electron. Okay, that would be negative 1.6, so that's negative 1.6 exponent minus 19. Okay, right. Right, so that's a very huge number. Okay, so that's going to be 1.25. Okay, let's see, that's 3, 6, 9, 12. Okay, all right, it looks like times 10 to the power 13. Am I correct? All right, electrons. So these would be, in fact, let me just use the symbol for electrons. All right, so that would be the number of electrons that in this case were transferred. Remember, it's the change in charge divided by the unit charge of an electron. All right. Okay, so that is how the cookie crumbles. All right. So the last question, they say, in which direction are the electrons transferred? Is it from A to B or from B to A? And I've just explained that to you. So in this case, it will be A to B. Okay, why? Because A has got a lesser negative charge, right? So it's got more electrons in it, right? So as a result, it will transfer electrons to B. All right, and essentially, ladies and gents, that is how the cookie crumbles. It sounded like, or it seems like it was a long question, but it is what it is, right? Otherwise, guys, I will see you again with the next question. I think it will be on circuits, right? Please look out for that later today. I'll see you guys again next time. Sharp, sharp.